Alpha Centauri System. How far is it really? Alpha Centauri is a triple-star system located about 25 trillion miles from Earth. Although this is a great distance in terrestrial terms, it is 3 times closer than the closest Sun-like star. The Chandra X-ray Observatory of NASA's Alpha Centauri research reveals that any planets orbiting the 2 brightest stars are unlikely to be pulsed by massive quantities of X-ray radiation from their host stars. This is critical for the viability of life outside the solar system in the nearest star system. Chandra X-ray data is shown in the framework of a visible light image taken from the ground of the Alpha Centauri system and its environments. Welcome to Brainbender Solarium. Join us as we travel through space and explore the Alpha Centauri system and learn how far it is from Earth. The nearest stars to Earth are the 3 stars of the Alpha Centauri system. The 2 main stars are Alpha Centauri A and Alpha Centauri B, which form a binary pair. They are 4.3 light-years from Earth on average. Proxima Centauri is the 3rd star. It's about 4.22 light-years from Earth, and it's the nearest star to us other than the Sun. How many years would it take to travel to the orbit of Alpha Centauri? Well, it will take about 100 years at an average speed of about 13,411 kilometers a second, or 4.5% of the speed of light. It takes another 4.39 years for data to begin to reach Earth. Every 80 years, Alpha Centauri A and B orbit a common center of gravity. There are around 23 astronomical units, or AUs, of the average distance between them. This distance is a bit more than the gap between the Sun and Uranus. The low-mass star Proxima Centauri is nearly 1/5 of a light-year, or 13,000 AUs, from the other 2 stars, a distance large enough that some astronomers question whether it should be considered part of the same system. Speaking about Proxima Centauri, it could either bypass the system and leave in a few million years, or be gravitationally bound to the binary pair. If it is bound, it has an orbital period of about 500,000 years around the other 2. A few years ago, astronomers revealed they had discovered an Earth-sized planet orbiting Proxima Centauri. According to researchers, the newly discovered world, known as Proxima b, is around 1.3 times larger than Earth. This exoplanet is also within the star's habitable zone, the just right range of distances where liquid water can be present. Proxima b lies only 4.7 million miles, or 7.5 million kilometers, from its host star and fulfills 1 orbit every 11.2 Earth days. As a result, the exoplanet is likely to be tidally locked, meaning that it shows the same face to its host star, much as the Moon shows just one face, the near side, to Earth. This means that one side of the planet would be very warm, while the other side would be very cold, unless winds could disperse the heat across the whole planet. It is not clear how habitable Proxima b is from today's telescope pictures. Astronomers need to run simulations and conduct comparative studies to better understand how habitable the exoplanet could be. As a starting point, the planet needs a closer look from investigators searching for a sign of an atmosphere. From there, investigators will extrapolate whether the atmosphere, if present, allows liquid water to flow on the surface. Even the surface temperature of the planet depends on the atmosphere. But the close distance of the exoplanet to the red dwarf star poses other issues. Red dwarfs are unstable stars, particularly when young. They have a lot of stellar activity and emit charged particles that can produce intense radiation on nearby planets. According to recent studies performed by the NASA Goddard Space Flight Center in Greenbelt, Maryland, some of this radiation will strip molecules off the surface of the planet's atmosphere and thin them over time. Studies of red dwarf stars are underway to better know the habitability of Proxima b. Lately, another planet in the habitable zone of a red dwarf has been found, almost as similar to Earth as Proxima b. This planet is named Ross 128b. And it orbits a red dwarf star that seems much quieter than the host star of Proxima b. Scientists say finding out more about Proxima B's atmosphere would require a next-generation telescope, such as the European Extremely Large Telescope, the Giant Magellan Telescope, or the 30-meter telescope, all of which are expected to be operational in the coming years. The James Webb Space Telescope, which is scheduled to launch soon, cannot search itself, as the planet does not travel via the face of its star. The two major stars, Alpha Centauri A and B, glow as one to the naked eye, making them the third brightest star in our night sky. The two different stars can be seen through a small telescope, one of the brightest binary stars. Proxima Centauri is too faint to be seen unaided, and telescopes reveal it is about 4 full moon diameters away from the other two. By itself, Alpha Centauri A, also known as Rigel Kentaurus, is the third brightest star in the night sky, just a little dimmer, 0.02 of magnitude, than Arcturus. It's the same type of yellow star, or G2, as the Sun, except it's around 25% bigger. Alpha Centauri B is a K2 type orange star, slightly smaller than the Sun. Proxima Centauri is a red dwarf around 7 times smaller than the Sun, or 1.5 times larger than Jupiter. All three stars are a little older, 4.85 billion years older than the Sun, which is 4.6 billion years old. The Alpha Centauri pattern is in the southern sky and is not apparent to observers above 29 degrees north, a line passing between Texas, Houston, and Orlando, Florida. It's easy to find in the southern hemisphere because the Southern Cross's cross-section from Delta to Beta Crucis points the way. Its right elevation is 14H 39M 41S, and its declination is minus 60 degrees 50 minutes and 7 seconds. Due to their nearness, the Alpha Centauri twins and Proxima Centauri offer an encouraging location to explore planets at a distance, particularly using direct imaging, if researchers can filter out the difficulties caused by the double star. But who knows, we might be visiting this star system in the future. Thanks for joining us. We hope you found this video interesting. If so, take a look at some of our other videos you see on the screen now. Also, ring that bell to keep up with new content that we publish weekly. We'll see you next time, here on Solarium.